And then vice versa, right? For the y-intercept, both of those y-intercepts, we've got the x is 0. So if you're looking for an x-intercept, turns out the y is 0. And the y-intercept, the x is 0. And so that's how we go about this finding of those when we don't have the graph to identify those. Find the x-intercept, well, like we just said, on the graph, those always have a y value of 0. So to find the x-intercept, we're going to set the y equal to 0 and solve. And vice versa, to find the y-intercept, since the x has to be 0 to be a y-intercept, we're going to set x equal to 0 and solve. So it's really hopefully easy process to remember. You just set, to find whatever intercept, you set the other one equal to 0. Okay. All right, so find the intercepts. Number 1. How about y equals 7 minus 2x? Usually the y-intercept is the easiest, so let's start with those. So like we said, to find the y-intercept, that's x is 0. And so that would be y equals 7 minus 2 times 0, just setting x to be 0, which makes that 0, which makes the y-intercept 7, or if we want to specifically write an ordered pair, it'd be x is 0, y is 7, right? It's x comma y. It's the usual order there. All right, x-intercepts. Well, we said the y equal to 0. And so that is a little more to it there. Yeah, we just set the y to be 0. And it sets up an equation that we do have to do a little solving for. Probably the easiest, either way, it doesn't matter. If we add the 2x and divide by 2, we got 7 halves. X is 7 halves, that's our x-intercept, or if we write it as an ordered pair, it'd be the x is 7 halves, the y is 0. So those are my intercepts. Fairly simple. You can run into all sorts of solving. I mean, that's why we talked about solving problems, solving equations earlier. What about this one? Intercepts on this one. Y equals x squared minus 4x minus 5. Most of our equations will be y equals equations, but they won't always be. So it may not always be just like this, but usually the y-intercept is the easier of the two. Won't always be. I think there might be one on the homework that is not, one or two that is not quite as easy as this. But the y-intercept, what do you got? 0 squared minus 4, the x is 0. Negative 5, yeah. Both the other terms are zeroed out, so yeah, you get a negative 5 y-intercept, or ordered pair form, 0 is x and negative 5 is y. The x-intercept, just a little more to it. Y is 0. So what we have to do there?
Factor.
Either factor, quadratic formula may come into play, square root method may come into play, but yeah, it is factor. X and x, got minus 5, minus 4 in the middle, minus 5 and a positive 1. Okay. And so in this case, there's two x-intercepts, yes. Add 5. X is 5, and here you got minus 1. X is negative 1. So 5, 0, we write it in ordered pair, 5, 0, negative 1, 0. Those are the actual x-intercept. So yeah, that one's going to cross the x-axis twice. Cross the y-axis once. Yeah, you can have more than one of each kind, but is that okay? All right. Let's talk about one other thing here. That is scatter plots. And good news is I have this on handout here. Save you a little bit of writing. All right, so in scatter plots, what I've got is I've got some data. And in this case, my data is year and then the life expectancy in years. So I've got 1920, 1930, 40, 50, and 60. And then the life expectancy, 54.1, 59.7, 62.9, 68.2, and then 69.7. Okay, so that's what you got there. Okay, yeah. So we'll do some more with this sort of thing later, but for right now, we're just talking about a scatter plot. Well, a scatter plot is just graphing the data, so it's really just what we were doing earlier with the table here. This is just a table here, and we're going to choose one to be x, one to be y. Of course, we'd probably choose the x here as the year, and then the y is the life expectancy. This is the way we'd probably most often see it. The other thing to note here is I'm only dealing with part of the Cartesian coordinate system here, the plane, the xy plane, because I'm starting x is at 1920, and then the y is only positive, well, it's larger positive numbers. So what I'm trying to say is, yeah, that really I'm only dealing with kind of the upper right quadrant of, instead of the whole thing. We don't have to draw the whole thing here, is what I'm getting at. Okay, so we're going to let x be the years, and so yeah, we'll let the year be over here. One thing I'd like you to do is label these so we'll know what this graph means. That's all a scatter plot is just a graph of the data. So we'll label those. Now the other thing is, I could put 1920, 1930, but let's go ahead and make a little bit of a shorthand notation, I guess you might call it. Let's go with the year 20, or yeah, x is 20, that's going to be 1920. So I don't have to write, I mean, could go ahead and write 1920, but probably make it look better if I do my years like that. So I've got 20, 30, 40, 50, 60. So whatever we do, just make a notation that that's what it means. Now over here, they're really, I mean, they're large numbers, but they're kind of packed together, and so I probably don't want to mark off a scale of 1 here, starting at 1, right? Because I would have to go 54 to 70 almost there. So let's make a little adjustment here. Let's start over here at 50. That'll be okay for our purposes. Start at 50, and then See, we're going up to 70, so mark off 2s, 5s. 5s will be fine, I think. Let's go 5, 55, 60, 65. Oops, what did I? So as you can tell, there's a little leeway here on how you do it. If you're doing your own, of course you'll have to, yours might be, I might skip what I've got in the handout there. Yeah, I might every 2 make a 5, I guess. Just so it'll get spread out enough. Those are judgment calls. You do what you want on those. All right. And then it's just plotting the data. We've got 20 is 54.1, and 30 is 59.7. Yours probably looks better. You got the grid there. 40 is 62.9. So let's say it's about, that's right about there. And 50 is 68.2. Right there. And that's almost 70 for 60. So. Yeah. So that's your scatter plot. Just plotting those points at all. Okay. Now, what we could then talk about, well, it looks like that's looking a lot like a line, isn't it? So that's where we'll go with this is then, well, that looks like a linear model, so I'll find a line for that. Maybe it looks like an x squared graph, so I'll do an x squared model. But anyway, that's all you have to do right now is plot it out. Question?